Hey, what's up? What's up? It is December 5th, 2025. We got a few things to do, nothing too crazy today. So make sure to take out all the things, and since you're at home, please check your own agenda. Make sure you get all that taken care of, okay? All right, pages 83 and 84, we did this yesterday, so hopefully you've got this all completed. If not, you can go back and look at the video. I have a video that's just on this, so you can watch that. That is due today, so make sure to go ahead and get that in. I'm going to get 15 minutes in class to, one, do sting session. Make sure you get this Explore number 1 turned in. Check whatever you need to do in Canvas and Aries. I've not updated. I will be grading tomorrow morning. I have set aside 2 hours to do grading. And then Explore number 2, so make sure you handle that. If you are ahead and got everything done, you can go ahead and start Explore number 2. Mr. Farr is not going to take that time to do that in this video. This is time that you need to take as a student. All right, y'all, let's keep it pushing. We're going to talk about this thing called scientific notation. So pay attention to the video.
Welcome to Math and Science. In this video, I'd like to talk about scientific notation, an easy way to write big numbers. Bill Gates has a net worth of $93 billion. This is a large number to write. A nanometer is 1/1000th of a meter, and it is written like this. Both of these numbers can be rewritten using scientific notation. Bill Gates' net worth can be rewritten as 9.3 times 10 to the 10th. A nanometer can be written as 1.0 times 10 to the negative 9. Let's go over some of the basics of scientific notations. Up first, the coefficient must be between 1 and 10. The exponent can be positive or negative, but it must be an integer. If you have to move the decimal to the left, the exponent will be positive. If you move the decimal to the right, the exponent will be negative. So let's look at 530,000. In this example, we do not have a decimal, so we can assume it's after the last zero. The coefficient must be between 1 and 10, so we need to move the decimal 5 places to the left, because 5.3 is between 1 and 10. The exponent will be positive because we moved the decimal to the left, and it can be rewritten as 5.3 times 10 to the 5th. In this next example, in order for the coefficient to be between 1 and 10, we need to move the decimal 4 places to the right. 7.8 is between 1 and 10. We need to move the decimal to the right, so the exponent will be negative. So the scientific notation will equal 7.8 times 10 to the negative 4th. So there we go, some basics of scientific notation. Thanks for watching.
All right, let's get on to getting on. Okay, there's that. Let me pause. All right, I have no idea where the camera is, but we're just not going to worry about that. So just go ahead and listen up, and then you can watch my cursor on the screen. So go ahead and take this as a note. Things that are important here. The coefficient, right, that is the number that's right here out in front. So again, write this down as a note in your journal. The coefficient is the number that's in front. You guys already know that this is the exponent here, but when we say it's an integer, what we are saying is that it needs to be what we would call a whole number, okay? That means no decimals. So whatever the exponent is, it is going to be a whole number. Pause the screen if you need this. Mr. Farr is going to the next slide. So again, write this down. The coefficient out in front needs to be between the numbers of what we would say 1 and 10. And every once in a while it might be lower than 0, but let's just follow with this rule. This rule holds true 95% of the time. Maybe even like 98% of the time. And then the exponent needs to be an integer or a whole number. Whoops, a whole number. Okay, let's go to the next thing. Mr. Farr wants to switch to blue because that's how I feel. Okay, now over here, whenever, and this is the way that I think of it, if the number is a large or big number, I would say big number, then the exponent, so a big number, right? I'm going to go put the hashtag for number, big number. That means that this exponent is going to be positive. If it is a small number, okay, then the exponent is going to be negative. That's how I like to think of it. Again, if you're moving it to the left, that means it's going to be positive, boom, and it's a big number. If you're moving it to the right, that means it's going to be negative, and it is going to be a small number. Again, take all these notes down. Write all these notes down. Mr. Farr is going to go to the next slide, but pause the screen if you need it and take these notes down. And again, I'll just walk this one more time. If it's a big number like 350,000, then the exponent is going to be positive, and you're going to move the decimal place to the left. If it is a small number, then the exponent is going to be negative, and you're going to move the decimal place to the right. So it's going to be like, boop, boop, right? And then I'm going to keep moving, and then I'm going to get here. So I finally get to the place where it is 6.0, right? So it actually would, oops, I got to move that one more decimal place, right? So 1, 2, 3, 4, 5. That's how we got to the negative 5. Okay, cool. Now Mr. Farr is going to move on to the next slide. Now, this is where you need to write down these numbers. So again, write down these numbers right here. These numbers right there. Write those numbers down. And then what you're going to need to do is try to put them in scientific notation. Again, pause the screen and try and put them into scientific notation. Students in class were hesitating. I'm like, no, just go for it. If it's right, it's right. And if it's wrong, it's wrong. Remember to follow the rules that we just watched and then the rules we just took notes on. So try to follow those rules and see if you can get it correct. So pause the screen, write down these numbers, and then see if you can get these correct. And then we'll go over here momentarily. Hey, be honest, fam. Did you go over these numbers? Please, I hope that you did. So let's go ahead and just walk through what they are. So for this top one right here, right, this is going to be a very small number. So it's going to move to the right, and the exponent's going to be negative, okay? So we're going to go 1. Oh, whoops, I have to take off my pen, I think. Yeah, turn that off. Boom, so I can get this to work right. Okay, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So that gives us a number between 1 and 10. So it would be 1.3 times 10 to the negative 8. And again, because we moved the decimals 8 times to the right. And remember, it's a small number, so the exponent is negative. Okay, this is a large number. So which way are we going to move the decimal? That is correct. To the left, so we're just going to go 1, 2, 3, 4, 5, 6, 7, right? Okay, cool. So then that would give us 4.56 times 10 to the what? To the 7th power. That is correct. So again, write these down. If you didn't get it right, hopefully this helps you with your understanding. We will practice more on Monday. Don't trip out, okay? All right, y'all, let's get to the last note with this hypothesis. And you're going to have to pause the screen on this one because there's not a lot to explain. You've heard of this word before. A hypothesis is an unproven theory, claim, statement, or prediction. Again, a hypothesis is an unproven theory, claim, statement, or prediction. So it's just like I was watching sports yesterday and they were making hypotheses or predictions about whether the Cowboys were going to win or lose. Some people were correct, but some people were incorrect. But again, at the time that they were giving these statements, right, they were hypotheses because they were unproven. And that probably is the biggest thing about a hypothesis. It is what we would call unproven at the time. But that's why we do the scientific experiment or play the games or do the thing so that we can prove whether it's correct or not. Now, on to the very last thing. Boom. We are on pages 85 and 86. If you have time to work on that, don't worry. We will have time in class to work on that. But make sure to bring in stuff for the canned food drive. And I know it says 4th period, but it really is 6th period. So bring it into your 6th period class. And then the very last thing is, it was brought to my attention that this weekend it is a 6-7 weekend. Right? So 6-7 was dictionary.com's word of the year, right? Origins are unclear, but kids use it to mean so-so, I guess, kind of, maybe this, maybe that, or just to have fun. Here's the other things, other finalists, which I thought this was kind of crazy. Aura farming. over tourism, and all these things are tied into, I would say, social media, except for tariff. That's tied into our president, and that obviously word was used a lot this year for adults and the government and things like that. So I can see why these are up there. Now, over tourism, that's about when people go film and say, this is a great place to go, and then everyone goes, right? Over tourism. So just remember, we only got 2 weeks left to go, and then we are on Christmas or winter break, whatever, holiday break, whatever you want to call that. So just lock in for the next 2 weeks. All right, y'all. Peace.